The first idea of contacts came from an inventor, Leonardo da Vinci, who created sketches in 1508 that showed how the eye could be altered by the cornea coming in contact with water. In 1888, the first glass contacts were made, and since then, plastic and glass versions of contacts have arrived. In 1971, the FDA approved soft contact lenses in the U.S. Contact lenses work by correcting vision by altering the way the light enters into the eye to focus it properly onto the retina. They work just like glasses do. They have a great ability to be altered based on an individual's unique eyesight, whether it be nearsightedness, farsightedness, or even astigmatism. This is a scanning electron microscope picture of contact lenses. Contact lenses are made of hydrogels, such as polyhydroethylmethacrylate, or PHYS for an abbreviation. These are polymer chains that are water absorbing, and they can also be using polydimethylsiloxane or polyvinylpyrrolidine. Also, some contacts are used to make your eyes look like different colors, in which case they would include pigments. Now, this composition has changed over time. Contacts started out as being glass and then became a glass and plastic mixture and now are made of mainly plastic hydrogels. I do not see any better alternatives for these materials because hydrogels have been used for the past years now, and they are used because they are better than glass and better than the glass and plastic lens mixtures. The material we will further discuss about is poly-2-hydroethylmethacrylate. Objects that contain this material include cell culture objects, in which this material prevents adhesion of the cells to the plastic material, wound dressing, and controlled release drug delivery.
Drahoslav Lim and Otto Wichtler-Lee were the two scientists who first discovered this material for biological use, specifically for the contact. It was perfect for contacts because it's a clear gel material that is able to soak up a great deal of water. It was synthesized in a solution of polymers that can be seen on the screen, and beyond contact lenses, it is also being used in 3D printed glass.
When contacts were first made, they were joined with wax or made out of glass. Today, people can either wear hard or soft contact lenses, but many people prefer soft contact lenses as they are more easily adjustable and more comfortable. Soft contact lenses are either silicone hydrogel lenses or just hydrogel lenses. The silicone hydrogel lenses allow more oxygen to reach the cornea through the lens and also allow for more comfort and better performance. Today, there are two ways that contact lenses can be made. The first is by lathe cutting, where small hard discs of contact lens material are placed on a spinning shaft that looks like a small pottery wheel. Once the lens material is placed on the wheel, it rotates at about 6,000 revolutions per minute while computerized cutting tools work to shape the lens. After the lens is shaped, it undergoes polishing and hydrating and is tested for quality. The second is injection molding, where soft contact lens material is heated until it becomes a liquid. The liquefied lens material is injected into pressurized, precise molds. Once the lens material takes the shape of the mold, it undergoes polishing and hydrating and is tested for quality. At the end of the process, a blue dye is added to the lenses so that they can be more easily seen if people drop them. Below is a link to a video on how to make contact lenses.
Through the use of contact lenses, our material has impacted approximately 130 million people in the United States and other developed countries. Overall, this material has made an incredibly positive impact on individuals who would have previously been dependent on glasses. Since the development of our material, contact lenses have become popular enough to establish their own industry or market. Because this is a medical product, the industry that is protected under policies to ensure that lenses reach the consumer without much advertisement or competition between companies. Regardless of this, investing in eye examinations and eye care through the use of our material has added millions of dollars to economies around the globe.
One cool thing about this material is that it is able to absorb between 10 to 600% of water relative to the dry mass of the material.